Assalamualaikum warahmatullahi wabarakatuh. So now we are going to look on experiment 4. The title is bridge. So our objective is to analyze a balanced and unbalanced Wheatstone bridge using Thevenin's theorem. You can read about the theoretical part on your own. So I'm going to explain about the instruction. So we can go to our pre-lab first. About the pre-lab in part A about the Wheatstone Bridge, you need to do your own calculation by referring to figure 4.8, which means you're going to use R1 equal to 2.3 kilo ohm, R2 and R3 as well as R4 equal to 2.2 kilo ohm by assuming Rg equal to 0 ohm. And you need to repeat on your step 1 with different values for R1, which will be 2.0 kilo ohm and 2.2 kilo ohm. So for this calculation, you're going to write the answer for inside this table 4.1 right here in the blue column. Okay, this one is the answer by using calculation from your pre-lab. Okay, so now we're going to continue with our procedure in part A, where we have here the Wheatstone bridge. Okay, so I hope you already have your lab manual. So you can refer your lab manual when you are watching this video. Okay, so we are going to look on our first instruction until our fifth instruction in order to fulfill our table 4.1. Okay, over despite the green cell, the purple cell, and the red cell. Okay, in order to get the answer from our practical part. Okay, so please refer your lab manual. We have here our first figure 4.8, the Wheatstone bridge. Second one, figure 4.9, Thevenin resistance circuit. And our figure 4.9b, the Thevenin equivalent circuit. So since I'm using a simulation to create or to develop the circuit, so I need to replace my galvanometer with my multimeter. Okay, so let's continue with our first instruction. At first, refer to figure 4.8. Okay, you need to set R1 equal to 2.3 kilo ohm. Okay, R2 equal to R2, sorry, R2 equal to R3 equal to R4 equal to 2.2 kilo ohm. So according to my simulation, let's look on step 1. Okay, so we have our Wheatstone bridge. So I already draw the Wheatstone bridge here. Okay, we have terminal point A, B, C, and D. Okay, I'm replacing my galvanometer with my multimeter. Okay, so now for this step, we are going to measure the value for Ig. Okay, if you refer your lab manual, the first instruction, you need to construct the circuit as in figure 4.8 and measure current Ig through the galvanometer, where you need to record all your result in table 4.1. So from our simulation, we have here between terminals C and D, I've put there our multimeter. So the reading, okay, from the current value is 0.04995 milliampere, or it almost equal to about 49.95 micro ampere. Okay, so the answer for our first instruction or our first step, you're going to write over here. Okay, right here where we have our resistor value equal to 2.3 kilo ohm. Okay, so from Wheatstone bridge, you're going to write the answer is here, where we have just now 49.95 microampere. Will be our first answer from step 1 to measure the Ig. Now, still you are using the resistor value of 2.3 kilo. So we are going to look on our second instruction. Okay. The second instruction, we need to remove the galvanometer, or actually it is the multimeter, from the circuit as in figure 4.8 and measure VTH from point C to point D. Okay, which means I'm going to show you from our second step here. So the point is C and D. Okay, so we need from the same